8 cities on a map. One vehicle starts at one of them, has to visit every other city exactly once, and then return to where it began. That is the entire problem. Now here is the obvious way to solve it. From wherever you are, drive to the nearest city you have not visited yet. Repeat until you run out of cities, then head home. It is simple, it is fast, and it is what almost everyone tries first. So here is the question. Does always driving to the nearest city give the shortest overall trip? Before the animation runs, commit to an answer, because your instinct here is the thing being tested. If every single step you take is the shortest step available to you, does the finished journey have to be short as well? Hold on to your answer. This matters well beyond a map of dots. It is the traveling salesman problem, and some version of it runs every time a delivery round is planned, an aircraft is routed, or a drill path is cut across a circuit board. Watch 2 answers run on the same map at the same time. The red route follows the nearest city rule at every step. The blue route sometimes chooses to travel farther than it needs to. Nothing else differs. Same cities, same starting point, same requirement to come home again. When both of them close their complete loop, the red route is 27% longer than the blue one. Sit with what that means for a moment. Red never once made a choice that looked wrong. Every segment it picked was genuinely the shortest one available at that moment. No city moved. No distance was hidden. There is no trick in the setup. And it still lost, clearly and measurably. So the mistake is not located in any single step, which means we cannot find it by looking at the steps. The mistake is in what the rule is measuring. Follow the red route as it builds. Early on it looks excellent. Each new segment is short, and each choice appears to be saving distance. But taking a city does something the rule never accounts for. It changes which cities are still available later. The rule has no memory of the alternatives it rejected, and no model at all of the trip home. Watch what happens in the middle of the build. 2 cities over on the right get collected early because they happen to be close together, and that is locally the correct call every time. Now watch the last third. Those early collections have left one city stranded on the far side of the map, and by the time the route is forced to go and get it, every nearby option is already used up. There is no cheap way back. That final long edge is not bad luck, and it is not a bug in the animation. It was made inevitable much earlier by choices that looked excellent at the time. The finished red tour measures 2.345 on this map's own scale, and every unit of that came from decisions which were individually correct. Now the exact answer. With the starting city fixed, there are exactly 5,040 possible orders to visit the rest. That is few enough to check all of them, so the solver does exactly that. It never judges an attractive first move, because it never looks at first moves at all. It only ever compares finished tour. Watch the blue route build, and notice how wrong it looks early on. It steps past a near neighbor to reach something farther away, which the red rule would never do. That looks like a mistake, and it is not. Those early concessions leave the remaining cities arranged so that the return journey is cheap, and paying a little more at the start buys back far more at the end. The blue tour totals 1.847 on the same scale. Both of those numbers come from the identical coordinates you have been watching this whole time, so nothing here is a different map or a kinder example. Put the two routes side by side, and now answer the question directly. What does the nearest city rule actually optimize at each step? Take a moment before the answer appears. Here it is. It optimizes only the next single move, never the finished loop. That single sentence is the entire difference between the two routes. Red is carefully solving a question about the next segment. Blue is solving a question about the whole journey. Those are different questions, they have different answers, and the measured cost of confusing them on this particular map is 27% longer. Now the honest limits, because this result is easy to overclaim. This is one generated map with 8 cities, not a proof about every possible map or every routing method. On plenty of layouts, the nearest city rule lands very close to optimal, and it is genuinely useful as a fast first guess. The failure is narrower and more interesting than saying greedy is bad. It is that a locally best move and a globally best plan are different claims, and nothing inside the rule can notice when the two come apart. So the answer is no. Always driving to the nearest city does not give the shortest overall trip. The takeaway is small enough to carry with you. A rule that is right at every step can still be wrong overall. So take it somewhere new. Where else might a locally best choice produce a globally worse result? Think about how you pack a bag, or how a compiler picks the next instruction to run. Same shape, same trap, completely different field.